Section 10.4 is talking about inscribed angles. An inscribed angle is something that is actually touching the edge of the circle versus a central angle, which is what we've been working on before. So, central angle, we saw that what we had before, it starts at the center, and if the arc is 80 degrees, the central angle is 80 degrees. An angle that's on the circle, and we're going to use the word on to go with center, and then the other two we have later on are in and out. Anything that's on the circle is actually half of the arc. So if that's 100, that means that's 50. This is on the circle because the vertex is a point that's physically on the circle. So even though it has a line outside, this is still half. That's still 60 degrees. So make sure you get this down. Let's go ahead and highlight it so you get the point that we really need to pay attention. Maybe we could put some smiley faces going around it so that way you see that we really need to write this down because smiley faces make everything important. So, find angle 1. Angle 1's over here. To find angle 1, I want to know what this arc is, and then I want to divide it by 2. Okay, so let's start with that being x, and then we'll find angle 1. Because this is 40 degrees, the arc that's across from it is going to be 80 degrees. Now I know 120, 80. All three arcs on a circle are going to add up to 360 degrees. So 200x equals 160. And since that's 160, I divide by 2 because angle 1 is on the circle. So the measure of angle 1 is 80 degrees. Another way you could have done that was, once I found this was 80, from C all the way around to B, this major arc, CAB, that's 200 degrees, meaning this angle is 100, and 100 plus 80 is 180. Example 2, angle COB, it's 90 degrees, it's a right angle. I want to find arc AC. So AC is what I need to find in the end. Since this is a 90-degree angle, that means this is a 90-degree arc. This is a straight line diameter, 90 and 90. The other way you could have done it, since triangle COB has two sides that are a radius of the circle, this is an isosceles right triangle, making that a 45-degree angle, and 45 times 2 is 90. Example 3. Two things I need to find, angle 1 and angle 2. Angle 1 is much easier to find since this is 40, over here's 80, and since this is a 180 degree semicircle, since that's 80, this is 100, and half of 100 means that the measure of angle 1 is 50 degrees. Now, for angle 2, the entire arc, this bottom arc that's matching the endpoints of angle 2 is 180 degrees, and half of 180 we divide by 2 to get the measure of angle 2 is 90 degrees. So let's take a look here. We know AB is 92 degrees. I want to find angle D, and I want to find angle C. Now, if we look at angle D has a line here and a line here that make up arc AB. So half of 92 is going to be 46 degrees. But when you look at angle C, that also does the same thing. Those two lines form arc AB. That's also, half of 92, that's 46. So because these two arcs cut off, these two angles cut off the same arc, those two angles end up being congruent. Example 5, let's try this. Angle P is 60 degrees. Arc PSR, so from P to S to R, this entire way around is 128. Since that's 128, I can find angle Q, because that is the line, or that's the angle that cuts off this arc. So half of, let's switch colors here, half of 128 is 64 degrees. Now, angle S actually cuts off the other part of the circle, the other half. So 360 minus 128 gets me that this side is 232, because 232 plus 128 equals 360 degrees, and half of 232 gets that the measure of angle S is going to be equal to that divided by 2, or 116 degrees. Now, since that's 116, what I need to do right now is look at the fact that it's a quadrilateral, it's a four-sided shape. So if I take 360, because that's how many degrees are in a four-sided shape, and I subtract 60, 64, and 116, I get the angle R is 120 degrees. Now, one thing I want to look at for a second, take a look at angle P. Let's switch to highlighter. Take a look at angle P. Take a look at angle R. 60 plus 120 is 180. Now take a look at these two. 116 plus 64 is also 180. Opposite angles in a quadrilateral add up to 180. So let's fill that one in first. The opposite angles of a quadrilateral are supplementary, meaning they add up to 180. And if an angle is inscribed in a semicircle, then it's a right angle. And that's looking at example 3 here. Angle 2 connects the two endpoints of a diameter. That's a right angle. In the last one, if two inscribed angles share congruent arcs, or the same arc, then they are also congruent. And we saw that in example 4, where these two, red and blue, shared the same arc, so they were congruent as well.